to our Wednesday lesson. Today, we're going to be talking a little bit about what we can and cannot assume from a diagram, and we're going to be talking about special angle pair relationships. Um, Sorry I can't be there today, but hopefully this video will help you out. Here is the homework that's due for today, and here's some of the work that you should have shown. You can pause the video and take a look at some of those answers. So we're going to start today with what we can and cannot assume from a diagram. Okay. So on this next frame here, there are some things that we can conclude from a diagram just by looking at it, and some things that we can't. Let's start off with things that we can conclude. Lines that appear to be straight are straight. So I have a little demonstration here. If you can see, this line right here looks like it's straight. And so because it appears to be straight, we can go ahead and assume that it is straight. And the second part is that any points that lie on the same line, we can assume are collinear. So we have here 3 points, C, D, and E, and they appear to be on the same line. And if they look like they're on the same line, then we can assume that they are on the line and that they are collinear. Now, there are things that we cannot assume from a diagram. So let's take a look at some of those things. We cannot assume that just because an angle appears to be right, that it is right. So I have a little angle right here, and this looks like it's a 90 degrees when you look at it. And you say, oh, that's a 90-degree angle right there. But then when we measure that angle, let me show you go to object properties here to show that to you. We show that angle, it's going to not actually be a right angle. There we go. So you can see that even though it looked like it was exactly 90 degrees, it's actually 90.7 degrees. Besides right angles, we cannot conclude that segments are congruent, even if they appear to be so. If we look over here, it looks like these two segments are exactly the same length if you look at them closely. Looks like OP and QR are the same length. When we put in the measurements, this one's 4.4 in length and this one's 4.3 in length. They're not actually congruent to each other. So just because they look like it doesn't make them congruent. And of course, we cannot assume that angles that appear to be congruent are in fact congruent. And I have a little demonstration over here, hopefully. These two angles look like they're congruent. And hopefully their measures show up. There we go. This one's actually 24.4 degrees. This one's 24.1 degrees. So even though they appear to be congruent, they're not actually congruent. So keep that in mind when you walk yourself through proofs, that you can't say that segments are congruent just because they look like it. So a little pop quiz here, and this appears in your workbook too. Based on this diagram, can we assume that this line AD is a straight line? Number 2, can we assume that BAC is a right angle? Number 3, can we assume that BCE is a straight angle? Number 4, can we assume that CD and DE are congruent segments? Number 5, can we assume that angles B and E are congruent just because they look like it? Number 6, can we assume that C, D, and E are non-collinear? C, D, and E, non-collinear. Number 7, can we assume that C is a point that's between B and E? Is that a safe assumption based on the diagram? Can we assume that E is to the right of A? Number 9, can we assume that CDE is an obtuse angle? And number 10, can we assume that BC is longer than CE? Take a minute, walk through that, and I'll pause the video and we'll take a look at some of those answers. Okay, can we assume that AD is a straight line? The answer is yes. BAC is a right angle? No, we cannot assume right angles. Number 3, BCE is straight? Yes, we can assume that. C, D, and DE are congruent segments? No, we cannot assume congruency. Same goes for number 5, angles B and E look to be congruent, but we cannot assume it. We can assume that C, D, and E are non-collinear because they're not on the same line. And we can assume that C is between B and E. The relative position of points would be a safe assumption. E is to the right of A. Yes, we can assume that. But we cannot assume that CDE is an obtuse angle, and we cannot assume that BC is longer than CE. Okay, let's turn our attention now to the second of our learning target, some angle pairs. And we'll start off with an angle bisector. And I'm going to move a little quickly here, but you can always pause the video and write some of these notes down. An angle bisector is defined as a ray, and that can also be a segment or a line, that divides an angle into two congruent angles. So here we have an angle, and this red would be an angle bisector if the top angle and the bottom angles are congruent to each other. So that would be your angle pair. Complementary angles are two angles that add to 90 degrees. These angles would be complementary if we knew their measurements. And if one of them is 40 and the other one is 50, then they are a complementary pair. Supplementary pair would be two angles that add up to 180 degrees. These angles will be supplementary if we know their measures. For example, if their measures are 40 and 140, then we know that those two angles are a supplementary pair. Adjacent angles, these angles right here are not adjacent, but we can make them adjacent as soon as we connect them. So now these two angles are adjacent, and if I slide this over, now these two angles are adjacent. Adjacent angles are two angles that share a same side. Now, a linear pair are two adjacent supplementary angles. So the angles that we see right here now that we've connected them, these now are a linear pair. And finally, a vertical pair of angles are two non-adjacent angles formed by intersecting lines. So when we look at this diagram, we have two lines that are intersecting. We know that angles 1 and 2, the red pair, are a vertical pair, as are angles 3 and 4, the blue pair. They're a vertical pair. If you combine a red angle with a blue angle, you get a linear pair. So angles 1 and 3 form this line right here, so they are a linear pair. 1 and 4 are a linear pair. Angles 2 and 3 are a linear pair, and angles 2 and 4 are a linear pair. So anytime we have one red with one blue in this case, they form a linear pair. So there's plenty of example problems in your workbook. Here we have some given information that we have a ray bisecting an angle. So to find these angle measures, we can take 4x, 3x plus 6, and set them equal to each other. And we can do that because of the word bisects here. An angle is bisected by a ray, divides the angle into two congruent parts. So set 4x equal to 3x plus 6. Similarly, 5x minus 11 set equal to 4x plus 1. You can find complements if angles 1 and 2 are a complementary pair of angles, and angle 1 is 80, angle 2 would be 10. If angle 2 is 10, then its supplement would be 170. Okay? And there's plenty of other examples as we move down on this worksheet. So take some time, work on this worksheet, hit pause on your video. I'll reveal some of these answers, and we will take a look at that. Okay? Okay, here are the answers for the first two. And here is the answers from the top half of the second page. And here are the answers to the bottom half of the second page. Okay, so I hope this helps.